Our talk today is on blockchain features for your applications. So a software development focused talk, and talk about ways that you might use blockchain features. So not cryptocurrency, even though cryptocurrency is a great blockchain application, one you might be interested in, this is really focused on the technology. So our plan today, we'll talk a little bit about the technology landscape, where this fits into things, talk about useful blockchain features, why would you care about some of this, what things you might pull into your applications. And then we'll talk a bit about some of the application choices. So this will be kind of a high-level talk, probably bring up lots of questions. You're like, wow, you mentioned this thing. How does that work? So good avenues of investigation and good discussion items for the group. Okay, I'm Gabe Hamilton. Picture me back when I was in His Majesty's or Her Majesty's Secret Service. I've had a career as an electrical engineer, mostly as a software engineer, but also started a few companies, been a manager, executive, and I'm back to being a regular software engineer now, which I really enjoy. There's my little graphical career path. Plenty of steps still to come, but you never know where your career will take you. There's lots of different interesting areas of business, areas of technology to explore. And each new one is kind of cool and refreshing. Okay, so just talking about computing. I mean, there's lots more technology outside of computing. We're talking about computing here. We'll talk a little bit about the landscape. And whether you're early in your career or later in your career, you'll learn some areas in depth, and or you might become more of a generalist and just learn how to put together lots of different technologies. That's more what I do. I know lots of different technologies to an intermediate degree. But in either case, you kind of want to know where different things fit. Like what can you do with databases? What can you do with what do you need to worry about in security, and how those different areas can be useful to you. So let's look at our made-up technology landscape here. Little AI art for us. So yeah, lots of different major areas that you might be interested in. Cloud infrastructure has been a really big one over the last 10 years. You can compose really big pieces of technology with that. Security is its whole entire giant landscape. Some people go really deep in databases. Databases are really powerful. Great thing to know about. Definitely something you want to know, what can a database do for me, even if you don't use it all the time on a daily basis. So, web applications, big area, tons that are not on here. Like, you could work for one of the national labs up in Boulder or Golden working on supercomputers, and, just totally different, focus and different sets of things you need to learn. User interfaces, great area. Machine learning, talk a bit more about that in a minute, but also a very large area. So blockchain, and a lot of people call some of the new blockchain stuff Web3. There's a lot of like open web kind of things done on blockchain. So this is another area of technology. So it's good to know about. It's got its own things you need to learn, and you might learn it in depth, or you might kind of pull in pieces of it and depend on some technologies. You might build on it and not need to know much about it, but a very useful area. Okay, so AI, machine learning is one of those areas we talked about there. That's definitely a very key area. That's an important one. You should certainly learn some of the contours of that. I mean, if you're learning software, you'll probably be using machine learning all the time as using a coding assistant. And pretty much everyone in society is moving into that area where machine learning is making us more productive. You'll be using some tools. You need to. The next generation of kids might be experts in it just because using it all the time. Certain area you can go deep into. Michael and Martin, for instance, here in the front row, are experts in machine learning. Went deep into that for many years. So great area, but also one you can just know the boundaries of as well and integrate it into other things. Okay, so I bring it up here partly to say it's more important than blockchain. Blockchain is this great, amazing area. AI is a slightly more important one. It's okay. You can learn both. You can know a bit about each. You can pick and choose between all these different areas of technology. But one of the reasons I moved from AI, I was doing a lot of AI the last 6-7 years, into blockchain is they go well together. So because it's such a hot topic, I'll delve into a little bit. As you have a more and more capable AI agent in the coming years, I think about how does that agent pay for things? So a lot of the services that you use right now, if you go on Facebook, go on Google, you're using Drive, whatever, you pay for those with your attention. And so, you're watching ads or you're buying products of some sort. Got a really cute puppy up here. So distracting my attention, speaking of. And so, that's kind of the economic model of a lot of services right now, which is really cool. So say you wanted to go, live in Italy for a little while. And, a great resource for that right now is like Facebook groups. You can go and talk to lots of other people who are doing that or have done that recently. So as a person, you might go and read a bunch of posts and ask some questions and things. But say you ask your AI agent that you have, next year or so to plan that trip for you. So, hey, I want to live in Italy for 3 months. Plan it out for me. Your agent's going to consume lots of data. It's going to go and look at all the Facebook groups or all the whatever resources are out there, fetch hundreds of thousands of reviews of different places and things to do. Might be able to go look at all of your friends' past recommendations in a way that like you can't. So on the one hand, it can't pay for things with its attention, and it wants to suck in lots more data than you can. So it's a lot more cost, a lot more expensive to do that. Maybe it looks at all the weather forecasts for the next 3 months. Maybe super cool, right? And all that. So how's your AI pay for that? Maybe it was paid to book all these things for your trip. It found all these great, AI focused ads. They're like, cool, great. I've pre-booked all your meals at McDonald's, just what you want, right? Because your AI got paid, something for that, or got that data for free, essentially. Whereas other more useful data, it had to pay for. So, there's a really interesting landscape that's going to develop over the next, decade around these things. And I think that blockchain and, the ability to do micropayments for data and to like verify what data was used in a decision is going to be really important. So that's where these things come together. That's a little bit of a tangent from the rest of the talk, but just something important to know, I feel like. Blockchains are good for, recording information. So you can kind of verify what your AI agent has done, like what sources of data it's used. So good for building applications like that people will build in the next decade for verifying a lot of that. But also good for, micropayments of various sorts. So it's like, great, if I can't pay for all these reviews and pieces of information with my attention, my agent can still, pay, a few cents for the different things and divide up payments for all that. That's easy to do with some blockchain technology. So it's a combination of things, verifiability and ability to like kind of chop up transactions and financial transactions into really small levels. So setting aside AI, let's focus on just like blockchain technology. So what should you know about the blockchain domain, this area of our landscape? Why is it different from just a database or security or other areas? Okay, so blockchain fits in the distributed systems area. We all work with distributed systems. We all have computers in our pockets or on our desk, talk to other computers. Anytime you've got 2 computers or 10,000 or a million computers, you've got a distributed system. And blockchain is an area of distributed systems. So we depend on distributed systems all over the place. Everything's distributed and connected these days. So we go to the textbook here to learn a little bit more. And we've got a nice complicated textbook sentence for us. So distributed consensus, ability to reach agreement in the face of failures and asynchrony. So lots of different computers talking to each other across time and space. It's a fundamental, powerful primitive for constructing reliable distributed systems from unreliable components. And all our components are unreliable. Our computers fail, our servers fail, things go wrong. That's part of life. Okay, so distributed consensus. So that's important. So that's what a blockchain is useful for. Blockchain is a way of agreeing on something between different computers. You're like, great, I'm doing this calculation, this computation. This network of computers is going to agree that I did that calculation. This was the result. It's fixed, it's immutable. Even if I'm trying to hack the system, this group of computers has a really good way of agreeing on what happened and saying like, nope, that's not what happened. You're trying to mess up this system. This is what actually happened. But in computing, we have to be fancy. We have to call it consensus, not just agreement. So I'm talking about consensus here. So that's what blockchains are good for. Consensus. Okay, so things you might use consensus for. Marketplaces of all sorts are an agreement on something. I mean, people tend to think of cryptocurrency when they think of blockchain, partly because agreeing on the value of things, agreeing on a transaction is very useful. That's pretty powerful. But you can have lots of other types of marketplaces that can involve different kinds of exchanges of value. I'll let you look at my data set if you let me look at your data set, in some equitable way. That could be a marketplace transaction you might mediate with some blockchain technology. interesting one I've seen recently is for fractions of a baseball card. You've got your, 1960, whatever, Mickey Mantle baseball card, super valuable. People want to buy like shares in that, thinking it's going to go up. People built things like that using blockchain technologies. Micropayments. So touched on this a little bit, but the ability to pay in, billionths of a cent can be kind of useful. Like, great, okay, that's 8 billion billionths of a cent for all that data. Here you go. You owe 8 cents for your research about the trip to Italy. So definitely really useful feature. And, there's lots of different kinds of payments. We get all kinds of points from, all the things we buy these days. Everybody's got some kind of reward program. So there's tons of different kinds of ways to structure financial transactions and reward different parties. And a lot of this actually happens in the real world. I used to work for a company that worked with food wholesalers. And just like the process of getting, avocados to your favorite restaurant involves all kinds of different incentives for the different players in there, and like kickbacks, depending on how many avocados were bought and like, during what periods. So as more of these things become more digital, blockchains are a great way to make them a little more visible and to enable a lot of these, kind of complex systems that exist in the real world that are complicated, but to make them simpler in a digital fashion. Registries. We talked about, blockchain is, an immutable way of recording information between different parties. So it's really great for registries. Or a registry, people think of that as art generally, because that's the kind of registry that took off recently financially, but really any kind of registry is a useful application for blockchain, particularly if you've got, a lot of different parties. So these are all kinds of features that if you need something like that in your application, you might reach for some blockchain technology. Like, oh, okay, I need some agreement between these different parties. I need a marketplace. I need some microtransactions. Great. I'm going to need some sort of blockchain technology for that. Or, you can build your own system, but computing, it's always really useful to just take stuff that other people have built and snap it together and have something new. Okay, so what sort of choices do you have in terms of, how you pull these different things in? And this is our last section, so we'll finish this up and then we'll do pizza here in just a minute. Okay, so you might use public blockchains. There's lots of different kinds. Ethereum is a really big one, Solana, Near, all kinds of different public blockchains. And those are the ones that you might know about if you've looked at cryptocurrencies a little bit. Those are all kind of distributed computation platforms. They're public, so like the information is out there publicly. That's a great feature, not always what you want. Sometimes you want it private. So if you're like, great, that's exactly what I need. I've got these different parties, but I want a private, you might have a private blockchain, one that, just the parties involved run. You might run your own ledger database. So you're like, oh, great, I want my own local blockchain. Maybe, you might still distribute it across the cloud or something, but you're running it all kind of yourself and you're treating it more like a database. And next month, we'll have a talk entirely on that subject on one of the oldest and best ones, FlurryDB. But this is actually becoming a more and more popular area. Microsoft now has some features like that. They're building into their databases. You're like, oh yeah, people want this kind of technology. So various providers of that. The inspiration for this talk was actually that you might not use a whole blockchain. You might just want one of these features. You're like, oh, I need to like prove that this data was calculated in this way for my, machine learning system. So you might want some mathematical proofs of that. And you don't need to build them yourselves because there's a lot of great work that's been done in the blockchain ecosystems for this. So you can be like, great, I'm going to pull in this library and start using it to prove this information. So zero knowledge proofs are another really cool area within proofs you might use that for. Blockchain involves a lot of different computers talking to each other to agree on something. So there's a lot of work on the kind of gossip protocols between all the servers. So you've got a bunch of servers you need to talk between. You might grab a gossip protocol library from some project or another. Same with some of these other areas. We'll dive into each of these here. Okay, so maybe you want the features of a public blockchain. It's going to be, it's public, it's well-known, well documented. There's a lot of people working in the space. So there's lots of different services and applications and features you can take advantage of. So definitely a cool option. Maybe, you've got some variant of LinkedIn that you're building. And, it involves like recommending your friends for like specific jobs or something, whatever your business idea is. So you could build up, reputation networks and recommendations. And in fact, you could say, okay, great, this particular blockchain looks interesting and it's already got some great social networks on it. Cool, I'm going to build on top of that. So that might be a good choice to give you, a very open system where everyone can see like, okay, great, these are exactly the recommendations that were made at this time, and these are the different attestations. So that can be really powerful. So we'll share the slides and the recording. I've got a link here to just some examples of social applications on public blockchains there. But there's plenty of different areas. That's just one I chose as an example. Okay, so private blockchain. There's been a lot of announcements recently about JP Morgan rolling out different private blockchains. This is one where it's different parties, different competing banks, for instance, and they want to work together. They want to say, this is how we're agreeing on certain data. This is how we're exchanging things. In this case, it's a lot of financial transactions. I bought this stock. Okay, you had it and you sold it to me. Great. There's no way you sold it to somebody else. Building those sort of systems. So maybe you get a job and you need to build a platform between different energy traders. So they need to cooperate on like what the state of the world is, who's traded what to who. But they're also fiercely competitive, so they they don't trust each other. You might build a private blockchain. You could build a public one too, but maybe some of that information needs to be kind of private from the rest of the world because it would affect futures prices or something, and other people could game it if they knew. Great, maybe you would build a private blockchain. Okay, for a lot of things you might use a ledger database. So you want something that's immutable. Maybe you're proving things by your AI system, but you're the only party. You don't have other parties involved in this. You're like, great, I'm going to run my own database. You might distribute it across different data centers, but it's still under your control. Great, ledger databases are really good choice for that. So a lot of cryptographic features. The immutability is really good for compliance. As you work for larger enterprises, you might run into lots of compliance programs where you've got to prove how was everything done. Was everything approved and checked off? Great, nice to have an immutable solution for that. And it's an area that's growing. More different providers of databases and things are adding ledger features. I'm like, oh, this is kind of cool. And if you use GitHub, you're using something pretty similar for each of your data is kind of like signing the other data and building up a chain. So GitHub is a pretty good model for how a blockchain works when you're just thinking about it conceptually. Okay, but if you're a software engineer, use libraries. Grab the libraries from these different projects. Most of the public chains and most of the private options are open source. So great libraries for cool hashing structures or zero knowledge proofs, consensus protocols, certainly, since that's at the core, and good things to pull into your application, maybe as a service, maybe as a library. Maybe you're setting up something that involves some kind of game theory incentives. That's great for blockchain. In fact, you can look at lots of examples and read white papers about how people have set up different blockchains and to work along with different game theory ideas. It's a really good area to learn. Event-driven features, actually another interesting one. Blockchain is, each new block has new events. So if you're building an event-driven system, a blockchain is an interesting model. There's a lot of things that then read from that series of events and do different processing. So even if you don't need the blockchain itself, you might use some cool, event-driven processing library that's built by some blockchain company. Okay, so that's the talk. I'm actually going to not do questions yet because we should do pizza here locally, but we'll do pizza. People can talk a little bit. We'll come back. We'll do questions for a little bit. And then after that, we'll jump into looking at some cool things that you wouldn't even know are running on blockchain and play around with them a little bit.